Today we are going to learn the effects of refraction. Firstly, we'll talk about bending of stick in water. Let's look at the image. When the stick is immersed inside water, the part of stick inside water appears bent. The reason for this is because the light which travels from this point O travels from water towards air. When it travels from water to air, actually it is traveling from a denser medium to rarer medium. And we have learned this, that when light travels from denser to rarer medium, it bends away from the normal. So when it bends away from the normal at point C and at point D, it reaches the observer's eye, and the observer thinks that the light is coming from this point I. So the stick from this surface of the water looks bent. Similarly, rising of coin placed at the bottom of the vessel. If you take a beaker and put a coin inside and put some water on top of it, the light from the coin reaches the surface of the water, and as it is traveling from denser to rarer medium, it will move away from the normal. And when the observer from this point looks at the coin appears to be raised, because simply the light is traveling from denser to rarer and it is moving away from the normal. Hence the coin appears raised from its actual depth. Refraction through a glass slab. Let's take a rectangular glass slab and let an incident ray be incident on its first surface. As the light is traveling from air to glass, that is from rarer to denser medium, the light will bend towards the normal. This bent ray, the refracted ray, as it reaches the second surface down here, it is traveling from glass to air, that is from denser to rarer medium. As it travels from denser to rarer, it will bend away from the normal. This ray, which emerges out of the glass slab, is called the emergent ray. If we trace back the emergent ray, then we'll see that there has been the shift of its actual path from its original or actual path to this point. So this is the shift of the actual incident ray. The incident ray and the emergent ray, they are always parallel when the light gets refracted through a rectangular glass slab. The emergent ray is always parallel to the incident ray only if the glass slab used is rectangular. Next is prism. A prism is a transparent object made of glass that has two opposite sides triangular and the remaining three sides rectangular. So there are two faces which are triangular, the first one and at the back, and there are three rectangular pieces, the first face out here, the second one out here at the back, and the third one down there at the bottom are rectangular sides. When the light passes through this kind of prism, then what happens? Let's take the triangular prism. And let's say there's an incident ray OL. From this point, the light is supposed to travel in this path. So the incident ray, when it is incident at the surface AB, since the light is traveling from air to glass, that is from rarer to denser medium, the light will bend towards the normal. So the incident ray is bent and it moves inside the glass towards the normal. At this point, when it is incident at this surface AC, the light, since it is traveling from the glass to air, that is from denser to rarer medium, it will bend again towards the away from the normal. Over here, the path of light, as we can see, is from this point. It moves inside the prism and again it emerges out of the prism in this way. Over here you can see this is the angle of incidence, this is the angle of refraction at the first point, and this is called del 1, that represents the deviation of the light. So this is supposed to be the actual path. OL is supposed to be the actual path, and here it suffers a deviation. Again, when it is traveling towards the second surface, it emerges out as an emergent ray, and this angle is the angle of emergence. This is the second refraction point, and this is the second deviation. This angle LMR, represents delta, that shows the angle of deviation. So this is the actual path of the light, and this is the emergent ray that has been bent because of the prism. The angle on top is called the angle of prism, which is represented by capital A. The relation between the incident ray, the angle of incidence, and the angle of emergence is shown as the angle of prism plus the angle of deviation. So angle of incidence and angle of emergence, if we add, the sum total will be equal to the angle of prism plus the angle of deviation. Refraction in nature. During sunrise and sunset. At sunrise, we see the sun 2 minutes before it actually rises above the horizon. This is simply because the rays of the sun enter the atmosphere from space and they bend towards the normal. The rays from the sun, which is just below the horizon, bend as they travel through the atmosphere. When these rays enter our eyes, it appears to us that the sun is above the horizon. Similarly, the same event happens during the sunset. We continue to see the sun even after it actually sets down. It has gone down below the horizon. Thus, we see the sunrise before the actual sunrise. We see the sun, and we see the sun still when it has gone down. The second phenomenon that we see at night is twinkling of the stars. The light from stars is refracted by various layers of atmosphere. The densities of these layers keep changing because of atmospheric disturbances. So the amount by which the rays keep changing and the position of the star appears to change makes the star twinkle. Heavenly bodies which are closer to us, like the planets, the moon, they do not twinkle because the intensity of their light is much stronger as they are very closer to the planet Earth. So they don't twinkle. But the light from the stars, which are very far away, are very feeble and weak. So those lights gets affected by the refraction through the layers of the atmosphere. Hence the stars twinkle. So with that we come to an end of our video. Hope you like it and you have understood the concept. Thank you.